In this video, we're going to talk about how we can write better code. So we often talk about the style of code, which is the way that we write it. In general, good code style means that you have made your code readable for other people. Often computers can interpret code written in many kinds of different styles, but some of those styles will be harder for humans to read and some of them will be easier. You also need to consider yourself. If you come back to this code in the future and you've forgotten exactly what it does, then making sure it's readable will make your life easier. It also makes it easier to spot bugs while you're writing the code and find them when you come to reread the code when you're debugging it. If you were to get a job in the future writing code professionally, you'd be expected to follow the code style of that company. And in general, most communities, such as companies or open source code organizations, will have conventions or style guidelines that they expect their contributors to follow. So one part of writing good code is making sure you pick clear and descriptive names for things like variables or functions. So here, for example, these names of these two variables tell you something about the values that are stored in them. So if we have a variable called student underscore scores and then a vector of 4 numbers, we can probably make an educated guess that these are scores that some students have achieved. If we have a variable called isPassing that stores the value true, then we can probably guess that this is the result of something like a test maybe, and something has passed that test. Much less clear. So if we just store the vector numbers in a variable called x, well, that doesn't really tell us very much about what on earth these numbers refer to. Similarly, test1 is not very helpful, right? Maybe there's a test, but like what's specific about test number 1, for example, versus test number 2? So ideally, if you're writing your code well and choosing good names for things, then your code should be relatively self-explanatory, right? Someone reading your code should be able to figure out what it's doing without too much struggle. So we don't expect you to explain your code step by step unless we explicitly ask you to do so. And if we do ask you to explain code, then ideally those explanations should be written outside of the code chunks. We're using R Markdown files, which means you can write written explanations as regular paragraphs, not inside code chunks. You can also use something called code comments, which allows you to write text within sections of code, although that's not the preferred method that we would recommend. So any line of code in R that begins with a hashtag symbol is what's called a comment. And that means that the contents of that line, anything after the hashtag, will be ignored. It won't actually be run. So in this first example, right, we have 3 lines. The middle line, the second line, starts with a hashtag. So this won't be run by R, which is lucky because this is not actually valid R code, right? It's a sentence describing why the code has been written the way it has. Ideally, if you're going to leave comments in your code, they should be explaining why you made certain decisions, right? You don't want to just write a comment like in this second example where you explain what the code is doing, right? Because if you say create a vector of scores, well, it's pretty self-explanatory from this line of code. That's what the code's doing, right? You don't need to restate that with a comment. Whereas in this example, right, we say we're removing outliers above 99 before calculating the average, and then we have this line of code here that is filtering the scores vector to remove anything above 99. Knowing that this is because of outliers is helpful for understanding this line of code, right? The code line 3 doesn't mention anything about outliers, so the comment does actually add some description to that. But as we previously said, right, in our Markdown, we can use written explanations outside of code chunks, so you should generally prefer those unless there's a very good explanation, a very good reason not to. We mentioned before that we want to write for humans. This code chunk here, this is valid R code. The R interpreter would be able to understand this and run it, but it's pretty hard for us to read it and see what's going on. But if we were to format the same code with much better code style, then it becomes a lot clearer. Right? We can see that we've got a for loop, and inside that we've got a conditional if statement, and then we're printing out some results. So good ways to organize your code are to split long lines up over multiple lines, right? Even though this is technically all one line of code, we can put line breaks within it to make it easier to read. So whenever we have nested code, we indent it 2 spaces. So each level of indentation here indicates a successive level of nesting. We've also put spaces around the operators, right? So for example, around the modulus operator, the double percent symbols, we've got spaces. Also around the equals, the double equals sign, which also make our code a lot easier to read. So it's a good idea to try to do this manually as much as possible, but RStudio also comes with tools that will fix code formatting for you to meet some of these criteria. And if you look up in the code menu at the top of RStudio, you can find some of these tools that will do some of the formatting of a code chunk for you. Another good thing to do is to try and avoid repetition. Once you find yourself repeating something, repeating a bit of code over and over again, it's a good idea to try and rewrite code to get rid of the repetition. So here we're running the calculate something function 3 times. Well, instead of writing it out 3 times, we could try to instead put it inside a loop. And then the loop iterates over the input data and stores the outputs in a list of results.